Hello students, this is the recording for the 3A Friction and Gravity lesson. Alright, so this is my contact information. I am Mrs. Larkin. Here's my phone number and my email. We do have some new students that started recently, so I do want them to know this information. Please remember that you do get 3 attempts on every assignment. Keep in mind that yesterday the Units 1 through 2 exam, the 2F exam, was due and is a huge part of your grade. So remember that once that's graded, they should be entered soon. That if you did not get the grade that you wanted, or if you haven't yet done it, you do get attempts to do it, and you'll still get your highest grade of your attempts. So keep in mind that Tuesday and Wednesday this week there are no live sessions for physical science, and specifically physical science, because I'm in teacher meetings for these 2 days. So instead you do have recordings and you do still have assignments. So we still have some notes on each of these days. And the extra credit has actually been moved to Wednesday. Thursday, we'll be back at our regular class. We will continue with our notes, and you'll have an attendance check due on that day, which is 10%. Remember, these count for 10% of your grade. And then Friday, we will have our next lab, the Net Force lab, and an optional support session. If you would like help on that lab, there is no live class on this day. And again, obviously, that lab is due on that day. All right, so let's go ahead and keep on going. So remember that the most important area of this course is the Grades tab. Keep in mind that the Grades tab does have links to all of your assignments and recordings. Especially for your notes, your recordings do have all the answers. For your labs, we go over all the steps, and for the exams, we go over all the questions together. So the easiest way to be successful is to be in the course, is to attend every single day that we have class, or to watch recordings on the days that we don't have class. And remember, attendance is 10% of your grade. New students especially, keep in mind that you do have STAR 360 reading and math due soon. So the instructions for how to find your username, password, as well as the link on how to log in is right here. So make sure that you please get that done. Old students, this is also required for you. So please make sure that if you haven't done it already, that you do. Again, for students who have already been here for 2 weeks, keep in mind that at this point we have completed the 1D lab report, and the 2F exam again was due yesterday. Together these both count as 30% for a total of 60% of your grade. So if you're not doing the labs and exams, it is impossible to pass the class. So you do need to make sure you get both of these done. And you can see here we also have had several notes. STAR 360 at this point is past due, as well as we have also had several attendance checks for class. If you started on, this should say Monday. If you started on Monday, you have a similar breakdown that you'll eventually see once you have more assignments in your gradebook. So you'll see that lab reports and exams do count for 60% of your grade. So your first lab will be the Unit 3 lab. The 3D lab on Friday. So that will be 60% of your grade, and you cannot pass without it. STAR 360 is worth 10%. Attendance again is 10% for live sessions, and then notes will be 20%. And notes we have due almost every day that we don't have labs or exams. And the answers for your notes are always in the class or in the recording. So we're starting a new unit. We're talking about Unit 3, Application of Forces. So we're going to take a look at friction and gravity and other types of forces in this unit. We'll talk about the concept of vectors, which are arrows that allow us to describe force in terms of vectors. So that's what we'll be taking a look at this unit. So today we should be able to identify and explore the different types of friction, explain the factors that affect gravity, and differentiate between mass and weight. So we're going to talk about friction force, types of friction, force due to gravity, mass versus weight, acceleration due to gravity, and then review and reflect. So at this point, you need to make sure that your notes are open, the 3A notes. Again, all of the answers to the notes are being provided word for word throughout this lesson. So you just need to start with it open, and I'll tell you when to begin filling it out. So click on your Content tab, go to Unit 3, Application of Forces, scroll down, find the 3A notes, and click Start Quiz. And again, this is actually also in your Grades tab, so that's another place where you could find your notes and the recordings and all the links, remember. So we're going to start off talking a little bit about friction, which is a force that resists motion. When it's done between moving objects, it's called kinetic friction, and between still objects, it's called static friction. So what is friction? Friction is the force that opposes the motion of an object, meaning that it goes in the opposite direction when that object is on a surface. So when you're trying to push an object across a surface, friction is what says, no, I don't want that to happen. So friction opposes or resists the motion. So remember that Newton's first law. Let's go ahead and get in here. Newton's first law says that an object in motion will stay in motion, stays in motion, until it is acted upon by an external force, okay? So this explains why when we slide an object across a surface, it does not move forever, because that friction is the external force that is slowing those objects down. So remember, Newton's first law again says it'll stay in motion unless there's an external force. And on Earth, unlike in space, that external force is oftentimes friction. All right, so this is the answer to number 1 in your notes. So make sure that in your notes you fill in the blank with the word opposes and only the word opposes. You only need to fill in what is in red. Pause the video, fill that out, and then continue playing when you are ready. All right, so there are 3 factors that affect friction, and the 3 factors are the object's matter, or what it's made of, so the material that the actual object's made of, the amount of mass, or how kind of similar to how heavy that object is, so the more mass it is, the more it affects friction, and then the surface's matter, or what the surface is made of, which should make sense, right? If you think about your shoe might be your matter, right? So the shoe might be the object, and then the surface might be ice, right? So you can think about, depending on the material of your shoe, whether it's rubber, whether it's metal spikes, right? Depending on the shoe material versus the surface material is going to affect the amount of friction and whether or not you can walk on that surface. And so speaking of which, friction is actually helpful. I know oftentimes we think of friction as like it's preventing me from moving a really heavy object I want to move, but really friction is useful. It allows you to sit at your computer because you would just slide off of your chair without friction. It allows you to type at the keyboard, same thing, your fingers would slide off of your keyboard and you wouldn't be able to type. And it allows us to walk, right? So if you can see down here that as you walk, you're actually applying a force against the ground, and friction is pushing back on you. And so as friction pushes back on you, it allows you to get traction on the ground and it allows you to move. And same thing, it allows you to touch things in general, like turning the page of a book. Now, friction and mass, we just talked about the mass of the object matters. So here's why it matters. When there's more mass, the surfaces actually press together with more force because gravity is actually pulling down on the object more. And this actually will increase friction because you can see that as you get heavier and heavier, the surfaces squeeze together closer and closer, which means that it's harder for the object to slide across that surface. So if you were to zoom in, you would see that, imagine that the surface is a very spiky, and then your object, as it gets squished into there, is going to have a harder and harder time moving. So more mass is going to result in increased friction. And that should make sense, right? If you think about moving an empty fridge versus a full fridge is going to be much harder to move. And the reason it's harder to move is because you're trying to work against friction. So let's think about this. Increasing the mass of an object on a surface results in increased friction, decreased friction, the same friction, or no friction. Take a few moments, pause the video, and think about the correct answer, and then play when you're ready. So the correct answer here is it should end up with increased friction. Again, we just talked about this, that the heavier the object is, the more it presses against the surface. And so as a result, it's harder for that object to move because of the increased friction from those two objects, the little spikes in the two objects being squished together more. This is number 2 in your notes. Go ahead, pause the video and answer this in your notes. Keep in mind that in your notes, the answers are scrambled. So make sure you actually read carefully and make sure you actually choose the one that says increased friction. Take a moment. Okay, so static friction is the resistance force between two non-moving objects. So we're going to learn there's 2 different types of friction. Keep in mind that the word static means that it's not moving. Like static electricity is electricity that doesn't move from your body, which is why when you finally touch something, you can shock it. or you get shocked, or for example, why your hair can stand on it. So the word static means that it stays, all right? So it's not moving, right? So static, you can think static stays. All right, so static friction means it's the resistance force when objects are not yet moving. So what this means is that you're trying to move the object, but static friction is preventing you from moving it. So it prevents an object that is at rest from being moved across a surface. So before the object can actually start moving, it first needs to overcome static friction, right? So this is why, for example, as you are trying to push a really heavy fridge across the ground, for a very long time, it's difficult to push that fridge, and the fridge does not move because static friction is working against you and preventing you from moving that object. Okay, so again, you can see here that the force of friction here is actually the same as the applied force, and so it's not allowing you to begin moving. So there's no motion here, okay? So really important. You can be pushing and there can still be no motion. Now, kinetic friction, the word kinetic means movement, all right? So kinetic means that it is in motion. So kinetic friction is the force that resists the motion of the object while it is in fact moving, while it's already sliding across the surface. So now you can see here that I have an applied force that's much larger, and because it's much larger than the force of friction that's resisting me as it moves, I'm allowed to move the object now. I have an acceleration because this applied force is larger. So what this all means is that as we have not moving, right? So when we're not moving and we're trying to push the object, we have static friction. You can see this right here in red. And this static friction actually increases with the amount that you push. So the more you push, the more static friction works against you. However, at some point, you become stronger than the amount of static friction. All right, and at that point, once you have enough force, the object will begin moving. And as soon as it begins to move, there's actually a transition to kinetic friction. And kinetic friction is always smaller than static friction, and that's why it's actually easier to push an object once it's already moving. And you've probably experienced this. Again, think back to our fridge example where you were pushing, nothing happened, and then suddenly it started moving slightly, and as soon as it started moving, it actually got easier to move, and then you were able to really push that object. So again, static friction increases while you push until it begins moving, and then kinetic friction is smaller and it makes it easier. This word begins is your fill in the blank for number 3. Take a moment, pause the video, answer that, and then continue playing. Okay, so that being said, let's make sure we understand this. So blank friction prevents an object at rest from starting to move, while blank friction resists the motion of an object that is already moving. So again, if you think about this, the object at rest means that is staying in its place, right? So it's staying in its place. And remember, when we think of the word stay, these first 3 letters, that should help us remember that this is actually static friction. Okay. While friction that resists the motion of an object that's already moving, remember that the motion, that when something's in motion, that's what we call kinetic. So this would be kinetic friction, kinetic meaning that it's actually already moving. Okay, so when you fill this, so when you choose this, your first blank is the word static and your second blank is the word kinetic. So you should choose the option that says static, kinetic. This is your answer to number 4. Go ahead and take a moment to pause the video, answer that, and then continue playing. And again, the answers will be randomized, so read carefully. Okay, so so friction again can be very, very useful, and it's important for us to understand how friction is affected with different materials. So the coefficient of friction is a number that describes the amount of friction between 2 objects. Now, this doesn't have units or anything. Instead, it's really just a ranking. So it ranks how different materials interact with each other. And how, and so we can understand that with bigger coefficients, it's going to be harder for things to move, whereas with smaller coefficients, it's going to be much easier for things to move. So for example, you can see here the static frictions, which is, again, how hard it is to get something to start moving. We can see here that we have some really low ones, which are Teflon on Teflon and Teflon on steel. So these ones would have really low coefficients of friction and be easier to move. whereas the highest one we can see here, I think, is 1.05, and that would be copper on cast iron, which would be very hard to move and would have high friction. Again, you can notice that as we go from static friction to kinetic friction and the object actually begins moving, kinetic friction again is smaller because once the object's moving, it actually gets easier to move the object against friction. This is number 5. Fill in the blank with the word coefficient. Pause the video and then continue playing when you have finished that. So our next topic that we need to talk about is gravity. So gravity increases with mass. It's a force between masses, and it accelerates objects towards each other. Let's take a look at it. Gravity is a force that an object exerts on another object, and it increases with mass. So it has to do with mass, right? So think about things that are really massive, like the sun or the earth or Jupiter. They all have high forces due to gravity because they all have a lot of mass. Now, remember that you and I actually also have mass, right? We're made of stuff. And so you and I actually also have our own gravitational fields. But because we are much smaller than the Earth, for example, our gravitational field doesn't seem that big, right? It doesn't seem to affect very many things. But it does mean that you are actually always attractive to things, or things are attracted to you. It's just very, very slight because your force of gravity is related to your much, much smaller mass. So gravity, again, it's a force and it attracts things to it. So now we need to talk about some important things here. So there are two different terms that we've talked about. So there's mass and there's weight. And mass and weight, we're going to learn, are not the same thing. So mass is the amount of matter or stuff that an object is made of. And this will always be the same no matter where you are in the universe, because you're always made up of the same amount of stuff. Now, weight, on the other hand, is actually going to be the force due to gravity on that mass. So it actually includes both the idea of mass, the stuff, as well as the gravity that's pulling down on the stuff. So it's actually, weight is actually a force. Mass is not a force, but weight is actually a force due to gravity based on the mass and gravity. Okay, so this right here is the equation for how you figure out weight. So you can see that here. So weight equals mass times the acceleration due to gravity. Or you could also say force due to gravity. So weight and force due to gravity are the same term. So weight is kind of how you and I talk about it in everyday life, but scientists actually say force due to gravity instead of weight. Because weight is a force, it is still measured in newtons, named after our famous scientist who came up with the 3 laws of motion. Mass is still measured in kilograms, and acceleration due to gravity is still measured in meters per second squared. Now, you should notice that this equation looks very similar because it is Newton's second law, which is that F equals m times a. The only thing that's changing here is that we put these little g's here to represent gravity. So force due to gravity is equal to mass times acceleration due to gravity. So it's still F equals ma, it's just in relation to gravity. Go ahead and fill in the blank for number 6 with the word weight. Pause the video and then continue playing when you're ready. Okay, so again, just to emphasize this and to give you a visual, mass and weight are not the same thing. Remember, mass is the same everywhere because you, no matter where you are in the universe, on Earth, on the moon, in outer space, you are always made up of the same amount of stuff, or the same amount of what we call matter. So your mass will be the same no matter where you are. So if you have a mass of 56 kilograms, you will always have a mass of 56 kilograms. Weight, on the other hand, or again, weight is actually a force based on gravity. Weight will change based on the acceleration due to gravity. So if you're on Earth, where acceleration due to gravity is higher, you will actually weigh more. So you can see here, this person has a weight or a force of 560 newtons on Earth, whereas on the moon, where the acceleration due to gravity is much smaller, they weigh less, even though their mass is still the same. So again, more gravity on Earth than on the moon, so you actually weigh more on Earth. But again, you still have the same mass. You always have the same mass. An important point here is that gravity does not rely on any other forces to exist. It is actually inherent to the universe. If you have mass, you have gravity. And so it is a fundamental force. Fundamental meaning a basic force to our universe. For number 7, fill in the blank with the word changes and only the word changes. Pause the video and continue playing when you're ready. Okay, so at this point you should know many things about gravity. So go ahead and take a moment to try to answer this question on your own. Which of the following is not true about gravity? A, it increases with more mass. B, it is higher on the moon than Earth. C, it is a fundamental force. Or D, it is a factor in weight. Pause for a moment, answer the question, and then continue playing when you're ready. Okay, so we want to figure out what things are not true about gravity. So gravity, it increases with more mass. This is actually true, right? So this is a true statement. The more mass you have, the more gravity you have, which is why the Earth has a large gravitational field, the moon has a smaller one, and you have one that is almost too hard to notice because you are too tiny. You have much less mass than the Earth and the moon. The sun, on the other hand, has a lot more mass, and the sun has a massive amount of gravity, which is why things revolve around the sun. Now, it's higher on the moon than the Earth. This one is actually false. Remember, we just talked about this. The Earth has more mass, and therefore, since it has more mass, it should also have more gravity, and the moon should have less gravity. So it should actually be lower on the moon than on the Earth. It is a fundamental force. We actually did talk about this. This is true. Again, gravity is not based on any other forces, meaning it is a basic force in and of itself, fundamental to the universe. That is true. And it is a factor in weight. And again, this is true, right? We said that weight is actually the force due to gravity, and forces equal mass times acceleration. And in this case, it's the acceleration due to gravity. So gravity is a factor in how much you weigh. So the answer here is that the false statement is that it's higher on the moon than on the Earth. Go ahead and answer number 8 in your notes, pause the video, and then continue playing when you're ready. All right, so the last thing that we need to talk about is kind of digging deeper into this idea of acceleration due to gravity. So gravity, again, is a force, and like all forces, it causes acceleration, okay? So it causes acceleration or changes in velocity. Changes in velocity, meaning that in this case, gravity speeds things up. Okay, so what this means is that when you drop a ball, it actually gets faster and faster the longer it drops, and it will hit the ground harder the longer it falls. So you can see this right here. If this object is starting at 0 meters per second, after 1 second, it's moving a little bit faster. After 5 seconds, though, it's moving much faster, significantly faster. You can see it's almost at 50 meters per second here. Now, this is important because this explains why we fear heights. Because if we were to fall from a short distance, right? Falling from a short distance, you don't fall for very long, and therefore you don't hit the ground very hard, right? Hitting the ground at 9.8 meters per second isn't going to be as scary as if you fall a much larger distance. So if you fall a much larger distance and you're falling for longer, you actually speed up faster and faster, which means that you hit the ground harder, which is why we fear heights. So what this means is that if there wasn't acceleration due to gravity, then objects would get to the ground at the same speed no matter their drop height, and then we would not be scared of heights, because that would just mean we would jump off at 2 meters per second, and then we would hit the ground at 2 meters per second, which would not hurt. Okay, so that's why it's important to understand that acceleration speeds things up. Now, how does this work? So you can see here that acceleration due to gravity on Earth is 9.8 meters per second squared. And what this means is that for every 1 second, we actually speed up an additional 9.8 meters per second, right? Meters per second is a speed, is a velocity. So what you can see here is after 1 second, the object has sped up to 9.8. After 2 seconds, it speeds up another 9.8 meters per second for a total of 19.6. After 3 seconds, you add another 9.8, so now it's moving at 29.4 meters per second, much faster. After 4 seconds, adding another 9.8, it's getting faster and faster, and you can see that it's falling faster down this cliff. Okay, so again, meters per second squared means that after every 1 second, it speeds up this amount. Okay, so this in your notes is number 9. Fill in the blank with the word acceleration. Pause the video and continue playing when you're ready. So that being said, you are on Mars, where the acceleration due to gravity is about 4 meters per second squared. So acceleration due to gravity equals 4 meters per second squared. So the question is, how fast would a ball be moving 3 seconds after you drop it? Now remember, what an acceleration due to gravity means is that for every 1 second, you actually are adding, that you fall, you're actually adding 4 meters per second of speed. right? So what this means is that if you start at 0 seconds, your velocity is at 0 meters per second. But after 1 second, so after 1 second, your velocity increases by 4. So now we're moving at 4 meters per second. The ball's moving faster. After 2 seconds, so after time equals 2 seconds, we add another 4 meters per second. So now the velocity is even faster, and the ball is moving at 8 meters per second. And finally, after 3 seconds of falling, we would add another 4 meters per second for this next second, and that would give me 12 meters per second. And so this would be my final velocity of the ball after 3 seconds. So your answer here should be 12 meters per second. Again, this idea that you get faster and faster and faster, 0 to 4 to 8 to 12, going much faster after 3 seconds than when you started. This is the answer to number 10. Pause the video, answer the question, and continue playing when you're ready. Okay, so at this point you should be able to identify and understand the different types of friction. We explained the factors that affect gravity, and we differentiated between what mass is versus what weight is. So go ahead and self-rate your understanding of today's objectives. Do you feel very confused? Do you still need some help? Do you feel pretty good? Do you feel awesome? Hopefully you're on this side of the scale, but if you do find that you're on this side of the scale, you can always come to me for extra help. You can email me, text me, call me, or there are also those optional support sessions. For this week, it's on Friday at 8:30 a.m. And then think to yourself or write it down, what is one thing that you either learned today or reviewed today? Keep in mind that you want to kind of solidify that learning inside of your brain. All right, and that's everything I have for you. Have a wonderful day. Thank you.